Earth is not sitting below the Milky Way, looking up at it from the outside. We are already deep inside the galaxy, surrounded by it in every direction. Tonight, we will drift from our sun through bright spiral arms and dark clouds toward the hidden center, and then beyond the bright disk into the quiet space around it. On a clear night, far from city lights, the Milky Way appears as a pale band across the sky. It can look like a soft cloud, but it is not a cloud in Earth's air. It is the crowded disk of our galaxy seen from inside. Countless distant stars blend together because they are too far away for our eyes to separate. Every star you have ever seen with your own eyes belongs to this same great home. Our planet circles the sun, and the sun travels with billions of other stars around the center of the galaxy. The Milky Way continues beyond the pale band we can see. It surrounds us even during the day, when sunlight hides the wider field of stars. Our route will cover distances that are hard to picture, so astronomers use a measure called a light year. A light year is the distance light travels in 1 year. Light moves so quickly that it can circle Earth more than 7 times in a single second. Yet it would still need more than 100,000 years to cross the bright disk of the Milky Way. The galaxy is so wide that no human journey could cross it. Even our fastest spacecraft would need far longer than human history. So this journey will follow light, maps, and the careful work of telescopes. We can move without hurry, letting each part of the galaxy appear for a moment before it fades behind us. We begin beside the sun, an ordinary star in a quiet part of the galactic disk. It is neither near the center nor close to the outer edge. It lies about 26,000 light years from the middle of the Milky Way. This distance places us in a calmer region, away from the most crowded fields of stars. The sun sits in a small branch of the galaxy called the Orion Spur. A spur is a shorter lane of stars and gas between larger spiral arms. Ours lies between the Sagittarius arm and the Perseus arm. It is a modest address inside a very large home, but it has held our solar system for about 4.5 billion years. Nothing around us is truly standing still. The sun carries Earth and the other planets around the galaxy at more than 500,000 miles per hour. That sounds incredibly fast. Yet the Milky Way is so large that one full orbit takes about 230 million years. One trip around the galaxy is sometimes called a galactic year. The last time the sun was near this part of its orbit, the first dinosaurs had not yet appeared on Earth. Since then, whole groups of life have risen and faded, while the solar system completed one slow circle. Human history covers only the smallest mark on that path. Tonight, however, there is no need to hold the whole scale at once. We can simply begin near home. Behind us is the small blue Earth. Ahead is the sun, bright enough to light every planet, moon, comet, and grain of dust in our solar system. Beyond the sun, the familiar planets become tiny points. Farther still, the sun itself begins to look like one star among many. The nearest star system beyond our own is Alpha Centauri. Its closest member, Proxima Centauri, is a little more than 4 light years away. That is close by galactic standards, but the gap is still immense. Most of the space between stars contains almost nothing that human eyes could see. The galaxy is full of stars, yet it is also full of distance. As we drift outward, the sun's light grows softer. Other nearby stars begin to stand apart. Some are larger than the sun. Many are much smaller. The most common stars are cool red dwarfs. They shine so faintly that not one can be seen with the naked eye from Earth, even though they are all around our part of the galaxy. A red dwarf uses its fuel very slowly. Some may continue shining for trillions of years, far longer than the universe has existed so far. Our sun is brighter and burns through its fuel more quickly. Massive blue stars live much shorter lives. The galaxy holds stars with very different clocks, all shining through their own part of time. Between the nearby stars are planets, small bodies, thin gas, and drifting dust. Astronomers have found planets around many kinds of stars. Some circle close to their suns. Others move through wide, cold paths. There may also be worlds with no star at all, traveling alone through the dark after being pushed away from the systems where they formed. From Earth, stars can look fixed, as if they have been pinned to a dark ceiling. Over long periods, their true motion becomes clear. Each star follows its own path through the galaxy. Groups that appear close together may slowly separate. New patterns form, and old constellations change shape. The night sky is a moving picture, shown at an almost still pace. Our local area contains open star clusters, loose families of stars that formed from the same cloud. One familiar example is the Pleiades, a small group that can be seen without a telescope. Its brightest members glow blue. The cluster is young, and over time, its stars will spread farther apart as the wider pull of the galaxy gently changes their paths. Farther away is the Orion Nebula, a bright place where stars are still being born. It lies roughly 1,500 light-years from Earth. Through a small telescope, it looks like a pale patch below the 3 stars of Orion's belt. In deeper images, it becomes a wide field of glowing gas, dark dust, and young stars hidden inside the cloud. The Orion Nebula reminds us that our part of the galaxy is not finished. New stars are still appearing. Old stars are still changing. Gas that once floated quietly can gather under gravity, grow warmer, and begin to shine. The Milky Way is not a completed object. It is a living pattern of matter moving through deep time. We are now far enough from the solar system to see the sun as a small golden point. Nothing marks it as the home of life. It does not sit at the center of a grand design. It is one star inside a local stream of stars, traveling around the galaxy with everything else. Its importance comes from where we began, not from how it looks at this distance. This change in view is one of the quiet gifts of astronomy. A familiar thing can become small without becoming meaningless. Earth can be a tiny world and still hold every human life. The sun can be one star among billions and still warm every ocean and forest we know. Scale does not remove meaning. It simply places meaning inside a larger space. We continue beyond the sun's local neighborhood and begin to notice the shape of the galactic disk. The Milky Way is often drawn as a bright spiral seen from above, but no spacecraft has traveled far enough to take that photograph. Every full image of our galaxy from the outside is a careful model made from measurements gathered within it. Mapping the Milky Way is a little like trying to map a forest while standing between the trees. Nearby trunks block the distant view. Paths overlap. Mist hides what lies ahead. Astronomers solve this by measuring the distance and movement of many stars. They also study radio waves and infrared light, which can pass through dust that blocks ordinary visible light. The European Gaia Space Telescope has measured nearly 2 billion stars. It records where they are, how bright they appear, and how they move. Each measurement is one point in a growing map. The map is still not complete, but it gives us the clearest view yet of the Milky Way from our place inside its crowded disk. Older drawings often showed the galaxy with a neat and simple set of arms. Newer maps suggest a less perfect shape. The Milky Way has several arms and smaller branches. Some are stronger than others. They may bend, break, and join in ways that are difficult to trace. Nature rarely draws a spiral with the clean lines of a symbol. Seen from above, the galaxy would look like a broad turning disk with a bright center. A long bar of stars crosses that center, and the spiral arms spread from the inner region. Dark lanes of dust wind beside bright areas of young stars. The whole shape spans more than 100,000 light-years from side to side. Seen from the side, the Milky Way would look much thinner. Most of its bright stars lie in a flat disk. A thinner layer holds many younger stars, while a thicker layer contains older stars moving above and below the main plane. Near the center, the disk rises into a crowded bulge filled mostly with older, warmer-colored stars. Our Orion spur is only one small feature in this structure. On one side lies the larger Perseus arm. On the other lies the Sagittarius arm. Deeper in are the Scutum Centaurus and Norma regions. Their names help astronomers share a map, but the borders are not hard walls. Stars and gas move through them over time. A spiral arm is not like a solid arm turning as one piece. It is closer to a slow traffic jam in space. Stars enter a crowded region, move through it, and later continue onward. Gas can be squeezed as it passes through. This pressure helps new stars form, so the arms often shine with young blue stars and glowing clouds. The traffic jam picture is only a simple guide, and astronomers are still learning how the arms form and change. Some arms may last for long periods. Others may fade and return in new shapes. The Milky Way is always moving, so its spiral pattern is not frozen. It is more like a slow wave passing through a wide sea of stars. We turn with that wide sea now. Around us, stars follow curved paths under the pull of the whole galaxy. The sun's orbit is only one of billions. Some stars move in nearly round paths. Others rise above the disk or cross it at an angle. Together, these different motions create the shape we see without any single star directing the rest. Gravity holds this great movement together. Every star pulls on every other star. though the pull between distant stars is very weak. Gas, dust, planets, black holes, and a large amount of unseen matter all add to the galaxy's gravity. The result is not a simple clockwork system. It is a deep, shifting balance that has lasted for billions of years. If we could watch the Milky Way from above for hundreds of millions of years, its motion would become clear. The disk would turn. Stars would cross the arms. Clouds would gather and break apart. Bright new stars would appear, while others would fade. The galaxy would seem less like a picture and more like weather moving across an enormous sky. We now enter a darker lane beside one of the spiral arms. The number of visible stars seems to fall, but the space is not empty. A cloud of dust blocks the light behind it. Dust in space is made of tiny, solid grains, much smaller than ordinary sand. These grains can hide whole fields of stars from visible light telescopes. This dust is part of the material between stars. Astronomers call the wider mixture the interstellar medium, which simply means the matter found in the space between stars. It includes thin gas, colder clouds, warm regions, dust, and fast-moving particles. Much of it is spread so lightly that a human traveler would not notice passing through. In some places, the gas gathers into great, cold clouds. These are called molecular clouds because they are cool and dense enough for atoms to join into molecules. They can stretch across hundreds of light years and hold many thousands of times the sun's mass. Their dark interiors are among the main places where new stars begin. Deep inside one of these clouds, gravity slowly draws gas and dust together. A small, dense region becomes heavier as more material falls toward it. The center warms under pressure. Over time, a young object called a protostar forms. It is not yet a full star, but it is gathering the material and heat that may allow it to shine. The cloud does not usually make only one star. Many dense pockets can collapse at once, creating a group of young stars. Some are born close together. Some form with companion stars. Around many of them, flat disks of leftover gas and dust begin to turn. Inside those disks, planets, moons, asteroids, and comets may slowly take shape. Star birth is quiet when measured against a human lifetime, but it is not gentle in every detail. Young stars can release strong winds and bright radiation. These forces push into the cloud around them. Cavities open. Thin walls of gas begin to glow. Dark material is shaped into pillars, ridges, and long curling edges. One well-known example is the Eagle Nebula, home to the pillars of creation. The pillars look solid in telescope images, but they are vast towers of gas and dust. New stars are forming inside them. Light and wind from nearby stars slowly wear their outer layers away, revealing a scene that is both an ending and a beginning. Another large nursery is the Omega Nebula, also called the Swan Nebula. It lies several thousand light-years from Earth and holds a wide field of glowing gas. Its light comes from atoms stirred by hot young stars. The colors in telescope images can show different kinds of gas, helping astronomers read the cloud's hidden structure. We drift past one of these glowing regions now. Bright young stars shine through openings in the cloud. Around them, darker areas remain closed to ordinary light. Infrared telescopes can see more deeply into those areas because infrared light passes through dust more easily. What looks empty to one telescope can look crowded to another. The Milky Way changes depending on the kind of light we use. In visible light, dust cuts dark paths across the bright band. In infrared, many hidden stars appear. Radio telescopes trace cold gas. X-ray telescopes reveal very hot matter and the remains of dead stars. Gamma-ray telescopes show the most energetic events in the galaxy. Human eyes see only a small part of the full galactic picture. This is not a weakness so much as a reminder. The world can hold more than one view at the same time. A dark cloud may also be a bright nursery. An empty patch may be filled with cold gas. A quiet sky may carry signals from events that happened thousands of years ago. Light takes time to travel, so every view of the Milky Way is also a view into the past. We see the Sun as it was about 8 minutes ago. We see Alpha Centauri as it was more than 4 years ago. A star on the far side of the galaxy may appear to us as it was tens of thousands of years before the present moment. There is no single image showing every part of the galaxy at the same time. Near and far regions reach us from different ages. The Milky Way we see is a gentle layering of old light, yet the changes are usually so slow that the map still feels whole. The galaxy allows us to study time by simply looking across distance. Inside the star-forming arms, massive stars shine with a blue-white light. They are much hotter and brighter than the sun, but they do not live for long. Their strong light comes at a cost. They use their fuel quickly, sometimes lasting only a few million years. In galactic time, their lives are brief flashes. Smaller stars live more slowly. Red dwarfs can keep shining for times far beyond the current age of the universe. Stars like the Sun lie between these extremes. They remain steady for billions of years before changing. The Milky Way contains all these different lives at once. Newborn stars, settled stars, aging giants, and quiet remains. When a massive star reaches the end of its fuel, its center can collapse. The outer layers may burst into space in a supernova. For a short time, one dying star can shine with the light of many stars. Together, the blast sends newly made elements into the galaxy, where they may later become part of new clouds and new worlds. Much of the matter in our bodies was shaped inside earlier stars. Carbon, oxygen, calcium, iron, and many other elements were made through the lives and deaths of stars before the Sun existed. The Milky Way has been reusing material for billions of years. Old stars return matter to space, and gravity gathers some of it again. This long recycling does not mean that every atom has followed a simple path. Matter can spend millions of years inside a star, then far longer inside a thin cloud. It may join a planet or remain in open space. The galaxy mixes its material slowly. carrying traces of many earlier events into every new system that forms. We leave the bright nursery behind and enter a wider field of older stars. Some have swollen into red giants. A red giant forms when a star like the Sun begins to run out of fuel in its center. Its outer layers expand and cool, giving the star a warmer color even as its total light may grow much brighter. Later, a sun-like star can release its outer layers into space. The remaining center becomes a white dwarf, a hot object about the size of Earth. It no longer makes energy in the way an active star does. It simply cools over a very long time, holding the dense remains of a star that once shone much like our Sun. More massive stars can leave stranger remains. Some become neutron stars, objects with more mass than the Sun, pressed into a space about the size of a city. A spinning neutron star may send beams of energy into space. If those beams sweep past Earth, telescopes detect a steady pulse, like a distant lighthouse turning in darkness. Other collapsed stars become black holes. A black hole is a region where gravity has become so strong that past a certain boundary, even light cannot escape. The Milky Way may contain many black holes left by dead stars. Most are difficult to find unless they pull gas from a nearby companion or bend the light of something behind them. Black holes are often described with loud and frightening words, but most of them move through the galaxy without disturbing distant systems. Their gravity follows the same rules as other objects with the same mass. A star or planet far away would not be pulled in without reason. Space is wide, and gravity grows much weaker with distance. Around us, some stars travel in pairs. Two stars may orbit a shared point for their entire lives. In wider groups, 3 or more stars can move together. From Earth, many points that look like single stars are actually small systems. Our Sun follows a different arrangement. It travels through the galaxy without a close stellar partner. We pass another open cluster, a loose gathering of young stars born together. The stars still share a general motion, but the cluster will not remain unchanged forever. Encounters with other stars and clouds slowly pull it apart. Its members spread into the disk, carrying a shared origin that may no longer be clear from their later positions. The Sun may also have formed inside a cluster. Its early neighbors have long since moved away. Somewhere in the galaxy, stars born from the same cloud may still be traveling on paths of their own. We do not yet know which stars they are. The Milky Way can separate families so slowly that the parting takes millions of years. Planets likely move around many of the stars we pass, though most are too faint to see directly. Telescopes often find them by watching a star dim as a planet crosses in front, or by measuring the small pull of a planet on its star. Each discovery adds another system to the galactic map, even when that system appears only as a change in light. Some of those planets may have skies with several suns. Some may circle cool red stars. Some may be hot, cold, rocky, cloudy, or unlike anything in our solar system. Science does not yet know whether any of them hold life. For now, Earth remains the only place where the galaxy is known to look back at itself. The stars become more crowded as we move inward. We are leaving the quieter region near the Orion Spur and approaching the inner Milky Way. Dust grows thicker along our path. The bright center is hidden behind it when viewed with ordinary light. From Earth, the middle of the galaxy lies in the direction of the constellation Sagittarius. If our eyes could see infrared light, much of the dust would become less of a barrier. A rich field of stars would appear behind the dark lanes. Infrared telescopes have opened this hidden view, showing that the center is not an empty shadow. It is one of the most crowded and active regions in the entire Milky Way. The inner galaxy rises into a broad bulge around the center. Many of its stars are older and redder than the young blue stars found in the arms. Running through the bulge is the galaxy's central bar, a long gathering of stars, gas, and dust. The spiral arms spread outward from this inner structure. The bar is not a solid beam. It is a pattern made by many stars following stretched paths around the center. Gas also moves along it. Some of that gas may be guided inward, where it can feed new star formation or approach the central black hole. The shape helps move material through the inner galaxy over very long periods. We cross into a region where the night sky would look very different from the sky above Earth. Stars are packed much closer together. NASA describes the central cluster as if about 1 million suns were placed inside the space between our sun and its nearest stellar neighbor. Darkness would still exist, but it would be filled with far more points of light. A planet here might never see the quiet, open constellations we know. Its sky could hold a bright, dust-filled band in every season. Nearby stars might change more quickly across the sky. Stronger radiation and close stellar encounters could make some parts of the central region difficult for stable planetary systems, though the full picture remains complex. At the very heart of this crowded field lies Sagittarius, a star. The name comes from its place in the direction of Sagittarius, and the word star is spoken because of the symbol used in its name. Sagittarius, a star, is a supermassive black hole with about 4 million times the mass of the Sun. The black hole itself gives off no light, so astronomers cannot see it in the ordinary way. They study the stars and hot gas moving around it. Some nearby stars travel in fast, tight paths. By following those paths for years, scientists can measure the hidden mass at the center, much as the motion of planets reveals the Sun's gravity. One star near the center completes an orbit in only about 16 years. Its path carries it close to the black hole and then back into the surrounding cluster. Watching this motion helped provide strong proof that an extremely massive and compact object sits there. The invisible center became clear through the movement of visible stars. In 2022, the Event Horizon Telescope team released the first image of Sagittarius A star. It was not a photograph of the black hole itself. It showed glowing material around a central dark area. Telescopes across Earth worked together like one planet-sized instrument to gather the radio signals needed to form the image. The image looked like a soft ring of warm light around a shadow. Gas near the black hole was moving so quickly that the view changed during the observations. Building one image required careful work across many nights and many locations. It was a picture made from patience, mathematics, and faint radio waves arriving from the center of our galaxy. Sagittarius A star is large in mass, but small beside the whole Milky Way. The galaxy does not spin because the black hole pulls every distant star around it. Most of the galaxy's gravity comes from all its stars, gas, dust, and dark matter together. The central black hole strongly controls only the region closest to it. At the moment, Sagittarius A star is fairly calm compared with the bright central black holes in some other galaxies. It is not feeding on a great amount of gas. Small amounts of material still approach it, producing changing light and heat. But the center of the Milky Way is much dimmer than the brilliant centers of active galaxies. The calm center may not always have been so quiet. Above and below the galactic disk are two huge structures called the Fermi bubbles. They can be seen in gamma rays, a very energetic form of light. Together, the bubbles stretch about 50,000 light-years from end to end, nearly half the width of the bright galactic disk. The Fermi bubbles may have formed after a powerful event near the center several million years ago. One possibility is that the central black hole took in a large cloud of gas and sent energy outward. Another possibility involves a strong period of star formation. Scientists are still studying the details, so the bubbles remain part fact and part open question. Human eyes cannot see gamma rays, which is why these enormous shapes remained hidden until modern instruments mapped the high-energy sky. Their discovery is a reminder that the familiar Milky Way has structures far larger than the band of stars we see at night. Some of its greatest features are written in kinds of light our eyes cannot detect. We pause near the center, where old stars, young stars, gas clouds, and a quiet giant share the same crowded region. The center is not one object. It is a layered place with many histories. Light from different instruments reveals different parts, and no single view can hold all of it at once. This may be the most striking idea in our journey. For most of human history, the center of our own galaxy was hidden behind dust. It was always there, shaping the motion of stars, yet we could not see through the dark lane. Only by learning to notice invisible forms of light did the hidden center begin to open. The darkness was not a blank space. It was a curtain. Behind it waited millions of stars, fast-moving gas, a black hole, and signs of ancient activity. The Milky Way did not change when we discovered these things. Our view changed. A larger reality had been present all along, quietly, beyond the range of ordinary sight. The curtain did not lift all at once. Radio waves traced gas, moving through the center. Infrared light passed through dust and revealed crowded fields of stars. X-rays showed matter heated to extreme temperatures, while gamma rays uncovered the vast bubbles rising above and below the disk. Each kind of light opened another part of the same hidden room. There is something quiet in this idea. The center did not need to be visible in order to shape the galaxy. It held stars in motion long before we understood what was there. Learning to see it did not create a new reality. It simply made our picture wider and reminded us that darkness can hold more than emptiness. We now begin moving away from the crowded center. The stars slowly spread apart. The bright bulge falls behind us, softened by dust. Ahead, the wide disk opens again, with its arms, dark lanes, and scattered nurseries. The journey becomes quieter as we rise above the main plane of the galaxy. From this higher view, the thinness of the disk becomes clearer. The Milky Way is very wide, but much thinner from top to bottom. Its youngest stars and much of its gas stay close to the central plane. Older stars can move farther above and below it, forming a thicker and softer layer around the bright disk. Rising farther, we enter the stellar halo. A halo is a wide, roughly round region surrounding the disk. It contains far fewer stars, so the view grows dark and open. The bright spiral becomes a distant shape below. Here, isolated old stars and ancient clusters travel on long paths around the galaxy. The halo is not an edge where the Milky Way suddenly ends. Galaxies do not have clear walls. The number of stars simply becomes smaller with distance. Gas reaches beyond the bright disk, and dark matter appears to spread much farther still. The galaxy fades outward rather than stopping at one sharp line. Scattered through the halo are globular clusters, round gatherings that can contain tens of thousands or even millions of stars. The Milky Way has more than 150 known globular clusters. Many formed more than 10 billion years ago, making them some of the oldest structures that still survive around our galaxy. We approach one of these clusters. From far away, it looks like a single soft globe of light. Closer in, the glow separates into a dense field of stars. They gather most tightly near the center. Many are old, small, and warm in color, though a few unusual blue stars can appear among them. A globular cluster is held together by gravity and can survive for billions of years. Its stars formed in the same broad period, so astronomers use clusters to study the early galaxy. Their ages and chemical patterns act like records. They preserve hints of what the Milky Way was like when it was still young and changing quickly. Some clusters move around the galaxy in directions opposite to much of the disk. This suggests that the Milky Way may have collected them from smaller galaxies in the past. Our galaxy did not grow alone. Over billions of years, it pulled in gas, stars, and whole small systems, adding their older paths to its own. The outer halo is also where the strongest evidence for dark matter becomes important. Dark matter does not give off or reflect light. Astronomers know it is present because of gravity. Stars and clusters move as if much more mass surrounds the galaxy than we can account for by adding up visible stars and gas. Dark matter remains one of the largest open questions in science. We do not yet know what it is made of. We can measure some of what its gravity does, but we cannot place it in an ordinary telescope image. In drawings, it is often shown as a wide, faint cloud around the galaxy, though the real material cannot be seen. Estimates of the Milky Way's total mass vary because much of that mass is invisible and spread across a huge area. One study, using the motion of globular clusters, placed it near 1.5 trillion times the mass of the Sun. The exact number may change as measurements improve, but the main lesson remains: visible stars are only part of the galaxy. From the halo, the Milky Way appears less like a flat picture and more like a layered home. The bright disk sits inside a thin spread of older stars. Globular clusters travel around it. Gas reaches outward. A much larger dark matter halo adds unseen gravity. Each layer follows a different shape, yet all belong to the same galaxy. The Milky Way is also not alone. Smaller galaxies move nearby as part of the local group, a family that includes the large Andromeda galaxy and many dwarf galaxies. Some of the smaller members travel close to the Milky Way and are affected by its gravity. They add another level to the slow motion around us. Two of the best-known neighbors are the Large and Small Magellanic Clouds. They are visible without a telescope from much of the southern hemisphere. To the eye, they look like faint pieces of cloud separated from the Milky Way. In fact, they are small galaxies with their own stars, gas, dust, and areas of active star birth. The Large Magellanic Cloud lies roughly 160,000 light-years from Earth. It contains billions of stars. Its shape is less orderly than the Milky Way's spiral, partly because gravity has disturbed it. The galaxy is passing close to the Milky Way, and the encounter has already pulled and pressed some of its surrounding gas. A long ribbon of gas, called the Magellanic Stream, stretches away from the two clouds and reaches around a large part of the sky. It cannot be seen with ordinary eyes, but radio telescopes can map it. The stream shows that galaxies can exchange and lose material as they move near one another. The Large Magellanic Cloud also contains the Tarantula Nebula, one of the most active star-forming regions in our nearby galactic neighborhood. New stars light its great clouds of gas. Though the cloud is much smaller than the Milky Way, it holds events bright enough to be studied across the wide gap between the two galaxies. These neighboring galaxies do not simply decorate the space around the Milky Way. Their gravity can affect its motion and shape. The Large Magellanic Cloud may even change predictions about the distant future path of our galaxy. A smaller companion can still matter when the movement continues for billions of years. We turn now toward the galaxy's past. The Milky Way did not appear in its present shape all at once. Parts of its thick disk began forming around 13 billion years ago, not long after the universe began. Early stars formed from simpler gas before many generations of stars had filled space with heavier elements. The young Milky Way grew by making stars and drawing in material. It also met smaller galaxies. Some were pulled apart and became part of the larger system. Their stars did not disappear. They continued on new paths, leaving long streams and unusual motions that telescopes can still trace today. In this way, the galaxy carries pieces of many earlier homes. A star in the halo may have formed inside a dwarf galaxy that no longer exists as a separate object. A globular cluster may have arrived during an ancient meeting. The Milky Way's history is written not in one book, but in the paths and chemistry of its stars. Gaia has helped astronomers read more of that history. By measuring how stars move, scientists can find groups following paths that do not match the main disk. These groups can be the remains of old galaxies. Their shapes have faded, but their motion still carries the memory of where they came from. The galaxy continues to change today. Stars are born. Stars die. Gas falls inward or is pushed outward. Smaller neighbors pass nearby. The spiral arms shift. None of this is fast enough to notice during one night. Yet the combined changes slowly remake the Milky Way across deep time. Far beyond the Milky Way lies Andromeda, the nearest large spiral galaxy. Its light takes about 2.5 million years to reach us. Under a dark sky, Andromeda can appear as a faint patch without a telescope. It is one of the most distant things the human eye can see on its own. For years, astronomers often said that the Milky Way and Andromeda would certainly collide and merge. Newer work has made that future less clear. A. Arlene R. Wool's study found that the paths of nearby galaxies leave roughly even chances of a merger or a miss during the next 10 billion years. The future remains open. This uncertainty is not a failure of science. It is what happens when better measurements reveal that a system is more complex than an older model allowed. The motion of the Large Magellanic Cloud and another nearby galaxy can change the result. In a group of galaxies, each member adds a small pull to the shared future. Whether Andromeda passes close or remains farther away, the Milky Way will keep changing. Its brightest massive stars will come and go. New stars will continue to form while enough cold gas remains. The spiral pattern may shift. The sun will follow its path through only a small part of this very long story. After so many names and distances, the details can begin to soften. The Milky Way does not need to remain a perfect map in the mind. It can settle into a few quiet images: a pale river above Earth, a dark cloud holding new stars, an ancient cluster, and a warm center hidden behind dust. From far above the disk, the Milky Way glows quietly below. The center is warm and bright. Dust draws dark lines through the arms. Small blue regions mark young stars. The outer disk fades gently. Around it, old clusters move through the halo, while unseen matter adds its steady pull. Across that wide disk, stars continue along paths that need no help from us. Clouds gather slowly. Old light moves through the darkness. Small worlds circle distant suns, and the whole galaxy turns at a pace too gentle for one night to reveal. The facts can fade now, while the quiet motion remains. We begin drifting back toward the Orion Spur. The bright center grows smaller behind us. The sun is still too faint to pick out among the surrounding stars, yet we know its place, between larger arms, moving through the disk, on a path that takes hundreds of millions of years to close. Closer now, one ordinary golden star begins to stand apart. Around it are the wide paths of cold outer worlds. Then the giant planets, the rocky planets, and finally Earth. The distances shrink from light years to light hours, then to light minutes. The galaxy remains around us, but home returns to the center of our view. Above Earth's night side, the Milky Way once again becomes a pale river across the sky. The band is the same galaxy we have crossed, flattened by distance and viewed from within. Dark patches are the dust clouds we passed. Brighter areas point toward crowded fields and the hidden center beyond them. Every point in that band has traveled before reaching your eyes. Some light began its journey before cities existed. Some began before modern humans walked the earth. It crossed cold space without knowing where it would arrive. And for one brief moment, it became part of a human view of the night. The Milky Way is enormous, but tonight it can remain simple. It is our galaxy, a wide home of stars, clouds, worlds, old clusters, and quiet motion. We do not need to remember every distance or name. It is enough to know that Earth is held inside this larger pattern, traveling with it through the dark. The solar system continues its slow galactic orbit. The spiral arms continue to change. New stars gather inside clouds we cannot see, while old light crosses the space between them. Nothing in the Milky Way needs our attention tonight. The galaxy can keep turning on its own, and the journey can fade softly into rest.